Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Fog of War 24 by Colleen Bridges, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Cells with the shaded square are even, so all of these cells are even. And cells adjacent to an x add up to 10. So for example, if this were say a 3, this would have to be 7, because these two digits must add up to 10. Black dots separate cells in the ratio 1 to 2. So say we had, imagine this black X was a black dot. If we say we had a 2 here, then this would have to be 1 or 4, because these need to be in a 1 to 2 ratio, because there's a black dot between them. White dots separate consecutive numbers. So say this blue X was a white dot. Then if we had, say, a 6 here, this would have to be 5 or 7, because these digits must be consecutive, because there's a white dot between them. Adjacent cells on green German whisper lines must differ by at least 5, and I will be calling them whisper 5 lines because a setter came up with that name, and I think it made a lot more sense because it's very easily extensible. So what's an example of that? Well, say we had, say we had a whisper 5 line like here, and say this was a 3, then these digits would have to be 8 or 9, because the only digits which are 5 or more away from 3 are only 8 and 9. Cells on blue region sum lines must sum to the same amount in each 3x3 region. I don't like this formulation of the rules because it leads to some ambiguity. The one I prefer would be box borders divide a blue line into segments such that each segment sums to the same number. So for example, if you had, say, a region sum line doing something like, say, this would be valid because this digit would be equal to the sum of these 3 digits, which would be equal to the sum of these 3 digits, which would be equal to the sum of these 2, which would be equal to the sum of these 2. Because the box borders divides the line into segments, all of which must sum to the same sum. If you read it the way that they have it here, cells on a blue region sum line must sum to the same amount in each 3x3 region, then these 3 would equal the same sum as these. And I don't think that's how it's meant to be. It could actually be that that's the way in this puzzle, but that's not the way that typically region sum lines are used. We'll have to basically determine whether that's the case, if there's a region sum line like this. Whether it could be, we'll have to keep it in mind that basically it could be either way. And that's why I don't like this. Well, it should probably be called something different then if it's not a region sum line, because this is the assumed preference for a region sum line, where box borders divide a region sum line into segments which sum to the same sum. But if you do have it so that these actually sum to the same sum, these 3 digits sum to the same sum as these 2, which sum to the same sum as these 3, you probably shouldn't be calling it a region sum line. But anyways, that's just my take on that. And we finally have numbers outside the grid are the sum of the numbers between 1 and 9 in that row or column, which is a sandwich sum. So, for example, we could have, say, a 1 here and a 9 here, and then this be 3, 5, and 4. And this would be valid because in this column, between the 1 and the 9, you have 3, 4, and 5, which add up to 12, which is the number given that's outside the grid. So that's an example of how these sandwich sums work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, these are all even digits here in box 3. Well, that counts for all the even digits in the box, right? Because there are only 4 even digits in each row, column, and box, 2, 4, 6, and 8. That means these must all be odd, and these add up to 10. So this must be a 1, 9, 3, 7 pair, which leaves this as a 5. Now, if this were 1 and 9 here to add up to 10, the problem is that you don't have 8 in between for the sandwich sum. So this cannot be 1 and 9. This must then be 1 and 9, and this is 3, 7 as a pair. Well, if this were 3 here, it would not be between the 1 and the 9 because we have a 1, 9 pair here. So if this were 3, that there would be no way to satisfy this sandwich because to have the digits between 1 and 9 sum to 3, it can only be just a singleton 3. So therefore this can't be 3, therefore it's 7, which makes this 3 there. These are definitely sandwich borders. Let's not color these this way then. Let's make these... The sandwich borders are... The crusts, essentially, are in red. That eliminates sandwich borders in the rest of the crust. And the rest of... let's not use blue. Let's use green. The rest cannot be sandwich crusts. This digit is in between 2 unique digits and in a 1 and 2 ratio with them. So the only possible digits that can work... Okay, so this has to be a 3 here. As I said, to have the 3 in between, it has to be between there and then a sandwich. So this cannot be sandwich. This is 1 and 9. This has to be 2, 4, 6, and 8. 3 is consecutive with 2 or 4. This digit is 2 or 4 because the only digits which are in a 1 and 2 ratio with 2 other unique digits are 2 and 4. 2 with 1 and 4 with 2 and 8. Now, if this were 2, this is consecutive with this digit, but it can't be a 3. So if 2 were here, therefore it would have to be 1 here, but then 2 would not be in a 1 and 2 ratio with 2 other unique digits because the 1 would already be taken by that box. So this cannot be 2, this must be 4. This digit has to be consecutive with 4, but it can't be 3, so this is 5. This must be 2, 8 as a pair then, to be in a 1 and 2 ratio. Neither of these are crusts. Okay. This is not crust either. It's 2 or 8. 1 and 9. Um... In column 4, the crusts have to be next to each other. Now, these cannot be crusts because we have a guaranteed crust already in the box. Also, this can't be going this way because you can't, if that's a crust here, then this would add up to, this doesn't add up to 11 for that to work. So these cannot be crust here. We can't have crust here. This is not crust here. Where is the second crust in box 2? It has to be here. So this has to be non-crust here, at least to add up to 11. We don't know where the crust is, but it must be 11 here. This cannot be crust because 2 and 3 or 4 and 3 only add up to 7. Can you have 4 digits adding up to 12 in between the 1 and the 9? The answer is no, because the minimum of 4 digits is 2, 3, 4, and 5, which is 14. So this must be 3 digits in between the crust here and here. That means the crust cannot be here anymore for the rest of the column. Crust can either be one of these two. These can't be crust because, again, they have to be next to another crust in the column because it adds up to 0. So this must be crust here. There must be a 6 here, and then this must be crust here. Because these, again, cannot be 0 because it can't be next to another crust. Because we have a guaranteed crust here. So then this is 6. It could be crust, 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 crust. We don't know. This could be crust here or crust here. Again, you can't have 4 digits in between, so these are neither of these are crust. Okay. So this is 1, 9 as a pair, and these are both crust, which eliminates crust in the rest of the box. So these are non-crust, which means there's crust here. So this must be a crust here. We don't know about this. One of these is a crust. One of these is a crust. Remaining digits in row 4 are 3, 5, and 7. This can't be 3. So these must add up to 12. It could be 2, 3, 7 or 3, 4, 5. Either of those work. These digits have a difference of 5. So one of them has to be 7 or 8 to be high, which means 4 cannot be here. So this is 2, 3 with 7 or 8 here. This is 1 or 9. Remaining digits in box 6 have to be 1, 9, 3, 6, or 7. No 3 or 7 here because of 3 or 7 in the column. No 1, 9 here because of 1, 9 in the column. Can we add up to 11 here for 3 digits? Okay, remaining digits in box 5. Well, this is 1 or 9. These cannot be 1 or 9. Can't be 3, 5, or 7, so it's 2, 4, 6, 8. That's interesting. So this is even, which means this digit cannot be even. It's odd. It's 3 or 7 because to be consecutive, you have to have an odd digit with an even digit. That makes this even here. Because again, cannot be 3, 5, 7, cannot be the crust, and that eliminates all the odd digits from those cells. One of these is 1 or 9. We're not sure which. So 3 or 7 is here. If this is 3, this would have to be 8. If this is 7, this would have to be 2. So this is 2 or 8 here. Hmm. Can we have 3 digits adding up to 11 here again? Yes, 3, 2, and 6 could work. We have 1 or 9 there. These are 2, 4, 6, 8. We have 2, 4, 6, 8 here. No 4 here because of 4 in the column. Huh. Where is... Well, no, never mind. So that adds up to 12. We don't know what this adds up to. Oh, this adds up to 27 between the crusts here. We already have 8 outside the crusts. So that means the crusts have to be at the end. Because 35, which is the numbers 2 through 8, added up together, subtracting out 8 gives you 27. So this has to be crust, which means none of these can be crust. So this is crust here. That eliminates crust in the rest of the column. So this is done. Let's mark the ones that are done. This is done. This is done. This is done now. 8 is not done. 12 is essentially done. 11's not done. 0's not done. This 6 is not done. You cannot have crust here, because then this doesn't have 5 to add up here. Crust can't be here because of the same problem. This is going to be at least 2, 3, and 4, which adds up to 9. So neither of these can be crusts, and since this can't be crust, we have to have crust here, and this is not crust and is 5. So that's done now. This is crust, so therefore crust has to be next to it to have 0 digits in between. So therefore this can't be crust here, which means this is crust there. So these 2 digits must add up to 11. Well, it's 3, 8, 5, 6, or 7, 4 here, so this can't be 2. This is obviously not crust here. You can't have crust in either of these 2 spots, because if you had a crust here or a crust here, it doesn't add up to 6 here. If you have crust here, you can't have a crust right next to it. If you have crust there, that's too many digits. If you have crust here, so this has to be crust and crust here. So we have crust here, crust here. Neither of these are crusts. So this must be non-crust. We have all the crust in the boxes here. And this, all the crust in the column. So therefore this is crust here. So this is done. And this must be a 6. So no 6 here because of 6 in the column. That's done. This is as well kind of done. This one's done. So we have to have crust here and here in row 9. And this must add up to 8. So then we have crust here, which means 6 and 2 have to be here. This can't be 6 because of 6 in the row. So that makes this 2, and that's 6. That eliminates 2 and 6 there, so it's 8. Obviously, no 6 there. So this is done as a sandwich clue. That 8 eliminates 8 in the rest of the box. 2 and 8 add up to 10, so this is 8. This adds up to 11 at most. So this cannot be 5 and 9 here. It has to be 1, which makes this 9. 1 eliminates 1 there, so that's 9, which makes that 1, which makes that 9, which makes that 1, which makes that 9. That makes that 1 and 9, which makes that 1. 9 eliminates 9 here, so it's 1 and 9. We don't know what these are. Okay. This is consecutive with this. This is 2, 4, 6, or 8. So this must be odd. It cannot be 1, 3, or 9. So this is 5 or 7 specifically. 5 and 7 are only consecutive with 4, 6, and 8. We have a 5, 7 pair also in the column. This can't be 1 or 9. So these 3 add up to these 2. So we could have 5, 1, 3. That adds up to 9, and 2 and 7 add up to 9. We cannot have a 9 here because this is 1 and 9, so this is 7 at most, and this is 3 at least, and therefore they add up to each other, so this must be 7 and 3 then. 7 eliminates 7 here, so it's 5, which is consecutive with 4 and 6. 5 eliminates 5 here, so it's 7. This must add up to 12, so it's 3, 7, and 2. This is done. This is done. 1 or 9 is consecutive only with 2 or 8. So this becomes a 2, 8 pair here. This adds up to 9. We cannot have 1 and 8 because of 1 and 8 in the column. So it's either 2, 7, 3, 6, or 4, 5. This can't be 6, so this can't be 3 there. This digit is 5 or more away from 9. It can't be 1, 2, or 3 because of 1, 2, 3 in the row. That makes that a 4, which eliminates 4, 5 as a pair in the box. Two and 8 pair in column 2 eliminates 2 and 8 in the rest of the column, so this can't be 2, which means this can't be 7. Remaining digits in row 7. We know this is a 1, 9 pair. We don't know which. We have 3 and 4 remaining, so this becomes a 3, 4 pair. What about, we have a 2, 4, 6 triplet in row 1, which eliminates 2, 4, and 6 in the rest of the row. That leaves the remaining digits as 3, 5, and 7. And 3 cannot be here because of 3 in the box. So this must be a 3 here, and that's 6, which means this can't be 6 here or 6 here. It's 2, 4 pair. This is 5 and 7. 2, 4 eliminates 2 and 4 in the rest of the box, so this can't be 2 or 4. It's 6. 8 eliminates 8 here, so it's 2 and 8. 3 eliminates 3 in the rest of the box. So this is a 6, 7 pair here. 2 eliminates 2 here, so that's 4 and 2. 1 eliminates 1 here, so that's 9, which makes that 1. The remaining digit in column 9 is a 4. Remaining digits in column 7 are 5 and 3. And this can't be 5 because of 5 in the row, so this is 3, which makes that 5. Remaining digits in column 7 are 6 are 4, 6, and 8. 4 and 6 cannot be here because of 4 or 6 in the row, so this is 8, which makes this 4 or 6. Remaining digits in row 8. We have 2 and 7 remaining as outside of the sandwich, the crust. So 2, 7 as a pair. We have a guaranteed 2 here. Remaining digits in column 2. We can't have a 2-8 pair. This is the crust, so it can't be 1, 9. So that leaves 5 and 7. And this can't be 7 because of 7 in the row. So that leaves that as 5, that as 7. 7 eliminates 7 here. So this is 3, which is 5 away from 8, which makes this a 2. 2 eliminates 2 here, so it's 7, which makes this 2. 2 cannot be consecutive with 9, so this must be 1, which makes this 9, which makes that 1, which makes that 9. 3 is consecutive with 2 or 4 here. Same with this. This is 2 or 4. Remaining digits in box 4 are 2, 4, and 5. This can't be 5 because of 5 in the row, so this must be 2 or 4. That makes this a 5. The 2, 4 pair in row 5 eliminates 2, 4 in the rest of the row, so this can't be 4. 8 eliminates 8 there, so that's 6, which makes this 7 and 6. 6 eliminates 6 here, so that's 4, which makes this 6. 4 eliminates 4 in the rest of the box, so this is 2, which makes that not 2, so it's 4, which makes that 2. This can't be 2, 4, or 6, which makes that 8. 4 eliminates 4 here, so it's 3, which makes this 4. We've got all the 1s, we've got all the 9s, 2s, we have 8 2s, we know where the last 2 has to be, it has to be there. 3, we don't have enough information. 4, the 4 in row 3 cannot be here because of 4 in the box, the rest are filled out, so 4 has to be there, and we have now 8 4s, so the last 4 has to be there. 5, we don't have enough information. 6s, we have 8 6s, so we know where the last 6 is, it has to be there. 7 in row 2, actually let's just do column 2, 7 can't be here because of, column 3 I should say. 7 can't be here because of 7 in the row, so 7 has to be there. And we don't have enough information to differentiate. 8. 8 in row 3. Row 2 has to be here. Row 3 has to be there. That gives us 8 8s, so therefore that's the last 8. Oh, these two add up to 11. So this must be then a 5, which makes that 3. 5 eliminates 5 here, so it's 7 and 5. That leaves this digit as 7 and this digit as a 3. And that's how you solve it. Pretty interesting mix of rules. Yeah, it's pretty straightforward. It flowed very well throughout. It was particularly the sandwich clues that was very instrumental in breaking this down. So highlighting the crusts where the crusts had to be, or could be, I should say, with what had to be in non-crust was very important for this solve. Yeah, overall, just a very well set puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.